Hello. In this video, I'm going to cover how to create a basic API web server using Node.js and Express. So you should have Node.js installed on your computer, and as you can see, I can say which node, and I have a node installed, and if I say node-v, I have version 22.8. So I'm going to go into my code folder, cd into squiggle/code or tilde/code, and then I will make a folder, mkdir node express API. So this is going to be an API server, and I will open it in code, VS Code. And the difference between an API server and a typical server is that an API server is meant to get data, whereas a regular web server is meant to get HTML. So for example, if you had an index.html file and you had some, basic HTML5 in here and some text, and you were to use Node.js, for example, as a development server, you might use something like npx live server to use the live server package from npm, the Node package manager, and then you could view your website on localhost 8080, for example, and then work on your website. And when you could also do something like an npm create vite at latest, or use create react app, or use any other sort of, the svelte scaffolding or the solid.js scaffolding to create some kind of project and initialize lots of files in your particular folder using Node. And so say you created a vanilla project, JavaScript, you would get some boilerplate code that you could use to build, say, a bundled site. And then you would use something like npm run build to build that code into a distribution folder, and then you would distribute that folder into any kind of web server you like that can serve HTML. And then it would function very similarly to just running live server, where you could serve the HTML page that is at your base path in that folder. Now, another thing that Node can be used for is to create dynamic applications that actually aren't just, in this case, we're just using Node as a way to run some bundlers, or we're just running some web server just for development. But what if we actually want to run Node at the runtime of our application? Meaning, rather than having, say, a static hosting platform like GitHub Pages, like if I go to gardella.cc, that is my GitHub Pages site with a custom domain, and this is being hosted by GitHub, so it's just files, and GitHub has the files. But what if I want to create an API server that's going to dynamically create data content for websites to use? I need some way to keep this application running all the time, and Node.js also has that capability. So I'm just going to rm-rf, this is a dangerous command, of /star, everything in the current directory, delete everything. I'm also going to delete the gitignore, and now we have an empty repository again, and we can just do an npm init. And I think we can do -y to just ignore all the questions and get kind of the defaults in here. So we get a package JSON with no dependencies and no script set up for us. And so it has the name being pulled here from the name of the folder maybe. And what we can do now is install different packages and run different JavaScript. So the simplest way to do this is we could just create a file, whatever we want to call it, say index.js, the default, and just say console.log hello world. And so now, when we're used to JavaScript files console logging, they are in the browser. if we've created like bundled code or we're importing JavaScript from HTML files. But when we just run JavaScript files with Node, we can just run node index.js and we can get the output of that file, and then it exits and it's done. Or we could run that in watch mode in newer versions of Node. Since I think Node 18, we can do -- watch. You might have seen in old tutorials, you might see NodeMon, the node monitoring or something like that, where you would automatically get updates if you changed this. But now you can just do node watch and you can get those updates live. And so you see that it runs the file just as if it were, a Python file or anything else. So that is one of the functions of Node, is just to be a JavaScript runtime for the computer that's not inside of the browser. And so we can use this sort of a model to create API servers where people can call this particular application. This application can bind to a port like port 80 or port 443 or port 3000, and then it can receive requests for data on that on those ports, and that's how an API server typically works. So this is not the server that would get the HTML for a site. It would rather be the server that gets data for a site. And so that server could be anywhere. It could be, a different, a certain website's API. Like you might see the IMDb API. You could find the documentation for the IMDb API and, see different fetch requests you could make on the IMDb API. And you would just essentially make fetch requests to wherever this data is and get data from the API server that the IMDb company is serving. So we're going to create something similar, except it's going to be on our local computer. So rather than calling, say, API dot, like calling API dot imdb.com, something like that, we would be just calling, localhost. We'll use something like 3003, localhost on port 3003. And websites can actually talk to localhost. We just have to make sure that we protect websites that we don't want talking to us from doing so. So, from just opening up a web browser, you have a JavaScript runtime in the browser as well. And so you can literally make fetch requests just like this. We can make a fetch request to HTTP localhost 3000, for example. And if that server is going to take requests, that request will actually come from whatever page you're on. So in this case, we're on google.com. The request would appear to come from google.com. So you'll see that in a bit, but essentially we're going to host an API server that will run locally on the computer, and as long as we have that running, websites, even websites deployed to the actual internet, can talk to our local server if we have that local server running. So we're going to use a popular library for making API servers in Node. There are many. You might have heard of Happy or some other API services, but a popular one is Express. So we're going to install Express and a middleware for Express. Don't worry if you don't know what that means yet, but it's a middleware for Express called Cores, so that we can deal with that protection factor that not just any website can talk to our local server in case we have private data. Only servers that we want to will be able to talk to us. So we'll do an npm I for install of Express, and we can separate with a space to also get the Cores package. So we're getting two packages in one command, and those should get updated in our package.json. And now we can also, let's say we want to change our index.js to be server.js to be a little bit more clear about what it's doing. And we'll change that here, server.js, and we'll make our, we'll do a familiar, maybe a dev script that does node watch, node -- watch, and then it will say server.js. And so then when we do npm run dev, we'll get that dev script to run watch server.js. And as we change server.js, then we can have different things being print it out in this case. Or we can do something much more interesting. So we can create an Express server. So the basic Express server, we can maybe get Copilot to give us some code, since this is a very common thing to do. Express basic server that responds JSON message hello on get to slash. So we're going to say when we get a get request, this is going to be an HTTP system. So when we get a get request on the slash path of our app, I want this to be 3003 for our port. I don't want require syntax because this is going to be a type module. So I'm going to go into package.json and say type of module, so that we can have familiar import modern syntax of import express from express. So now we have a server running on 3003, and if we change the port, we would see, and we save, then that'll get updated by the node watch to update what's happening in our server. And so this just kind of hangs. This keeps running. It doesn't exit because the server has to keep listening for requests on port 3003. And we have this response of a JSON data of message hello. And now the browser will do something nice for us and allow us to see JSON data, but keep in mind that this is not HTML. This is JSON data that's coming back. It's application/JSON would be the MIME type on this data rather than text HTML or something like that. So we'll see localhost 3003, and we'll see message hello comes back. We could even select pretty print to get kind of nice JSON syntax here, but essentially we're just getting back that data, and this is JSON data. It's not HTML. We could respond with some HTML if we wanted to, but we would have to do some different things, and that wouldn't be an API server anymore. That would just be a web server, a dynamic web server at that point. So now what we're going to do in this app is essentially just do something very simple, return some random numbers. So say we have 1, 2, 3, 4, 5, something like this. We're going to do just, eventually we want this to respond with a JSON array, so not an object, but just a flat array, and that array is going to have 17 random numbers. So const n numbers equals 17 numbers, and then I want function get random is going to be the min, take the min, or we could just default this to be 100. So it's going to be a random number from 0 to 100. So rand from 0 to 100. And we can return math.floor of math.random times 101. So now we can call this a couple of times. We could use something like array.from length and numbers, and for each item it's going to produce the item with the getRandom function. And so that's doing exactly what we want. Every time we reload, make a new get request is what reload does. Makes a new get request. We're having now dynamic content. So it's not like a standard web server that gives you back the same HTML file or the same CSS file every time you ask for that URL. Instead, we're getting different dynamic content because the server is doing an action live. And the other key of that is that once Node is no longer running, the server is no longer accessible. So that's when you have an API server running, you have to keep that thing up constantly. Just like GitHub has to keep its GitHub Pages servers running all the time for your site to be accessible, you have to keep an API server running 24/7 if you want it to have 24/7 availability. So this is a pretty good basic app. And the last thing that you really need to do here is specify different origins that can talk to this app. So let's see what happens when we just try to go to google.com. We're on google.com right now, and we're going to go into the inspector, and we're going to try to go in the console and run a fetch request. So we're going to ask Copilot to, looking at our file, say write a JS fetch for this. So it's going to use the built-in JavaScript fetch API to fetch localhost 3003, just like we do when we enter in the browser, except our origin here is null. We're doing this just from nowhere. And we're going to get the JSON data from that, turn the result of this into JSON data, and then console log the data and report any errors. So I'll copy that code to the clipboard and I'll literally paste it into the console here, and you'll see that we get access to fetch at localhost 3003 from the origin is www.google.com with HTTPS, and that whole thing is part of that origin. So if we want to have cores in here, let's say we want to modify our current file. Let's add open cores to the file. And that's just going to use the cores package that we installed, cross-origin resource sharing, which essentially says any origin, any website like google.com or vccs.edu or GitHub pages, sites, any website can call this server. Now that's dangerous if you have sensitive data being served, but we just have random numbers. So it's really no issue to have this middleware from cores be added to our Express app. And middlewares are a bit confusing, but essentially the idea is that Express lets you have this little module that HTTP requests will flow through as they get processed by the Express app. So that happens in an asynchronous manner. You don't explicitly say every step you want to happen. You just say, when these requests come through, do these things. And so one of the things we're going to do is enable cross-origin resource sharing using the HTTP headers. And this just takes care of that for us. So we have to import cores as well to get that to happen. And so now when we try the same fetch request, we'll see that it comes back. And so the default cores is just super open. It's letting anyone talk to our app. But maybe we want to be more specific, where we want to specify the origins for this so that it's not just anyone can talk to us. So that would be a good place to look at the Express documentation. We'll search Express.js, or sorry, the cores documentation. So cores npm docs origins. And if we find the documentation, Express cores npm docs. Okay, here's Express cores middleware. We'll find you can install the cores package like we did, and you can use the cores package. So what about the origin? Find that you can configure for specific origins. And so here's an example where we can specify the cores options, and then the cores options get passed into that cores middleware. So here you will need to specify the origin is either one of the options that you can use. So I click that link and it says origin can be a Boolean, string, a regular expression, an array, which can be strings or regular expressions, and then a function. So let's use the array version so we can set multiple versions. So we'll do const cores options, call that anything, and we'll make that an array, sorry, an object which will have origins, origin, and our origin object, const origin, our origins can be an array of regular expressions or strings. So let's say by default localhost is going to the null origin is going to be pretty permissive and let us view this because that's just how things are working by default. But when we go to any actual website, we're going to have that be a problem. So if we were to, let's say, restrict this very specifically to only localhost addresses. So let's use a regular expression, a regex tester, to make sure that we build our regex correctly. Regular expressions are just a way to match multiple strings based on a little formatting language. So we can also use Copilot to help us with regexes. It's pretty good at those. So we can say a regex or regex for any local host address, whether HTTP or HTTPS, any port. So we can copy that, insert it here, and then we can test it out. So if we had HTTP colon slash slash localhost colon 80, would that work? Yeah, that would work. What about just localhost? That would not work. So we need to maybe make this D plus part, the digits for the port. We need to wrap that in a group and make sure it's optional. Between 0 and 1 times. Between 1 and unlimited times. So let's say make the port optional. No. We want make the port optional in the regex. And I'm going to hide that file so it doesn't get confused. So let's see, yeah, now it's adding the question mark. We'll copy that. The colon is going to say, I think, to not capture that group, perhaps. And it was the question mark, but it needed the colon included in that group. So localhost is fine. Localhost 80, 809, 888 is fine. Nothing is fine. It can be secure, it can be insecure, it can be 90 insecure. Anything in that arena is going to work fine. So now I'm happy with this regular expression, and I can copy it. And in JavaScript, you can do regular expressions with 2 forward slashes and then some stuff in between. So the forward slashes are going to go there, and we're just going to, it already had forward slashes, so you see that coloring there indicates that it's being correctly included. And so if this regular expression is gibberish to you, that's fine. That's why you need to test your regular expressions. There's a whole language you can learn, but we're just trying to match multiple options here with one particular setting. We could also be very, very specific though, since we know, for example, Google is going to be calling from https://www.google.com. We can just give a string with that extremely specific string. Now, if anything goes awry, like for example, Google doesn't use secure SSL, or if Google doesn't use the www subdomain, or if Google uses a different port, now all of a sudden this core setting is not going to work. But at least for this particular thing, this particular page where we're at right now, that fetch request should work just fine. So we can see if we go here and we request, we get that data back just fine. But if we take out the google.com thing, or we even change it to Google and we misspell it, then we will hopefully get an error. And we're not getting an error because we haven't passed the cores options into cores. So there we go, and let's pass that. We get an error. We go back to the one specific Google one, and I think I have a syntax error now. So there, it comes back fine. Getting confused with different terminal syntaxes, but make that fetch request, we're fine. We misspell it, we're not fine. Even something as simple as you think, well, it's just google.com, or it's just www.google.com. If you don't include that, the origin actually includes that that portion as well. And you may think this is like a lot of information, like unnecessary stuff to know, but origin matching is going to be super important if you're trying to harden the security on your API servers. So we're specifically only letting localhost addresses, so our local PC, if we were to have another local site that we were calling from, and google.com, when we have that correct, are the only websites that are going to be able to ask for this data. And that way Google could literally display these numbers inside of its HTML if it knew about our server, which is the really cool thing. But right now I want to restrict that and maybe not let Google do it, but let say any vccs.edu websites, maybe they can do that. So I'll do a regex for any vccs.edu site or subdomain, but only with SSL. So I don't want HTTP alone, I want only the SSL versions of those sites. And so I'll copy this. I can make this a little simpler by just using .star. So here we can say, rather than this, we can just say .star, so 0 or unlimited of anything. And this will match the dot character. So if we say https vccs.edu, this will be fine. If we do subd.vccs.edu, that's fine. We're not going to accept ports other than 443, so we're only going to do HTTPS sites. And we can also make sure that we had like s.sub. whatever, multiple subdomains, that's fine. And it's not going to include the actual path at the end, so we shouldn't have to worry about that part. We should find, though, that we have no matches when we go down to insecure, and when we need to add that security in order to get the matching. So there, any VCCS edu domain or subdomain is allowed to talk to our server, only if it has SSL configured. So we'll replace, or we can just add that alongside google.com. Then we'll wrap this in a slash and a slash to make it a regex. So this is a regex or a regex, and this is a string, and this is a regex. So now those are the only origins that can talk to us. And that's made it so now we could go to, say, Canvas, like learn.vccs.edu. We'd go to Canvas, and even though this is portal.my and it has all this slash stuff after, if I go to the console with F12 and I paste that same fetch request from somewhere along the way, then I can get that data back. And that's because the origin here is the origin I'm expecting and allowing. Whereas you can't just go to some random thing, like you couldn't just go to, say, nr.edu, because we haven't allowed that origin, even though it's associated with the same organization, sort of. As far as the origins are concerned, if we try to run the same code here, we're going to see that the origin nr.edu, www.nr.edu, is not something that the CORS policy is going to allow. So we're being very restrictive, so we make sure that we're only talking to the people or the sites that we think we want to talk to. And that way you have control over, if you have control over domains, so say I have control over google.com, which I do not, then I could be sure that any sites calling me from there are going to be legit sites. And they're going to be sites that I trust to get my data from. And so that's a really important security feature of API servers, that if you don't have, say you're not using a CORS middleware at all, it's a good default that nobody can talk to you. So when we have no CORS, we're not allowed to have this data conversation between the nr.edu and localhost or any of these, even the ones that were allowed. You don't get to have that conversation. But if you allow CORS, just allowing it outright is going to be a little risky, because then anyone can talk to you. Like nr.edu could now talk to us, even though it's not listed in our CORS policies, because we're just doing open CORS. Anyone can SRRs, or can share our resources across origins, CO. So now, if we want to harden that security a little bit, we want to actually restrict to the specific origins that we want to talk to us. So in this case, VCCS, Google, and localhost addresses are fine to talk to us. So that should conclude this video. Thank you for watching.